Hello everyone, you're welcome back to this channel. In this video, you're going to solve this question I have on the board. The question says, determine whether the 250 Newton crate will slide or tip over when a 60 Newton force is applied as shown below. Assume the crate's weight acts through its geometric center and the coefficient of static friction between the floor and the crate is 0.3. Will the crate remain in static equilibrium? Let's find out. So let's start by determining whether the crate will tip over or not. Okay, so let's go ahead and look at that. Let me draw the free body diagram for the figure that I was given. Okay, so we have the applied force here, which is 60 newtons. Okay, and then its distance from the bottom here is 0.9 meters. Okay, and then you have this distance here to be 1.8 meters. And this distance here is 0.6 meters. And we have our weight force here, which is 250 newtons. So now let's indicate the normal reaction force and then the friction force. So we're going to have the normal reaction force to be concentrated at the point of rotation. Okay, and then the friction force to be here also. All right, so now if this crate is going to tip, we will be expecting it to tip in this direction, which is the clockwise direction. Let's consider it to be positive. Okay, so if the crate will tip, that will be the direction of tipping. Okay, so as a result of that, the normal reaction force and then the friction force will be concentrated at just this point here. Okay, so that's why I have a normal reaction force and then the friction force acting at that point here, which is the point of rotation D. Okay, now I want to determine whether the crate will tip over or not. So what are the conditions that you are going to use to determine this? So what you do is that you calculate for the resultant moment. Okay, if you calculate for the resultant moment and it is less than or equal to 0, then that means tipping will not occur. Okay, but if you calculate for the resultant moment and it is greater than 0, then that means tipping will occur. Okay, so let's keep these two conditions. So now you are going to calculate for the resultant moment. Okay, and then compare it to these conditions and then determine whether the crate will tip or not. So now let's calculate for the resultant moment. We're going to have sum of moment about the point of rotation D. So that would be equal to, let's calculate the moment caused by this 60 Newton force here. Okay, so that will cause a clockwise moment, which is positive. So I'm going to have 60 newtons multiplying with 0.9. Okay, and this weight force will cause counterclockwise moment, which would be in this direction, right? And you know that's a negative direction, right? So that would be minus 250 multiplying with 0.3 meters, right? So let's see what you're going to get. So we have 60 newtons multiplying 0.9 minus 250 multiplying with 0.13. So this will give us the resultant moment to be minus 2118 meters. Okay. So let's compare it to these conditions. This value here is a negative value, which means it is less than 0, right? So which means this condition holds, right? And we say that if the resultant moment is less than or equal to 0, then that means tipping will not occur. But if it is greater than 0, then that means tipping will occur. Why is it so? So look at something here. You're expecting tipping to occur in this direction. Okay. But here is the case, the resultant moment is negative, which means that it is rather than in this direction. That means that tipping is not going to occur. Okay, because the resultant moment that we calculated is actually going in the direction opposite to the direction that we expect tipping to occur at. So as a result of that, tipping is not going to occur. Okay, because the direction that we expect tipping to occur in is actually opposite towards the direction of the resultant moment. Okay, so in this case, tipping will not occur and then the crate will be in static equilibrium. Okay, so let's look at the second part, which says that we should determine whether the crate will slide or not. Okay, so let's look at that. So for the crate to slide, the applied force must be what higher than what the maximum friction force, right? So let's determine that. So for us to know whether the crate will slide, we are going to calculate for the maximum friction force and then compare it to what the applied force and see which one is bigger. Okay, so now we're going to have the maximum friction force to be equal to the coefficient of static friction multiplied with the normal reaction, right? In this case, we know that the normal reaction will be opposing the weight force. Okay, so the normal reaction will also be equal to what? 250 newtons, right? So I'm going to have the maximum friction to be equal to the coefficient of static friction, which was 0.3 multiplied with 250 newtons, right? Okay. So we're going to have 0.3 multiplied with 250, and then that gives us the maximum friction to be equal to what? 75 newtons. Okay, so what is happening is that we have the maximum friction to be higher than what the applied force. Okay, so because of that, the crate will not slide. This is because the applied force is not higher than what the maximum friction, which means that it is not high enough to cause what sliding to what. Okay, so therefore the crate will not slide. So the crate will rather be what in equilibrium for both cases that we are afterward to consider. That's all for this video. Thank you very much for watching, and please, if you haven't subscribed to the channel, kindly subscribe to the channel and also like this video. Thank you.